Yeah, Zoom or Discord, screen shares either. Yeah. It doesn't have to be that day. That's awful. Like the next day, like if you're it'd be easier. Go to my Calendly link. I'll put the slots you can snag. No, it'll just be. Yeah, it'll just be. I'm doing that individual class. Really get people all at one time. Like an apple. But we've got a last day, and then this should be probably the last. Let me double check this. I write it down because yeah, I think so. Next week is the advanced GUI stuff. So more GUI stuff, and then the week after that's just work time. That's on the point. Correctness, robustness, and not efficiency. Just for separate. Yep. Oh, that's cool. Nice. I'm sure they'll balance it out eventually. All right. We got good? Oh, you see? Let's see. I pushed the right button. There we go. All right. Happy Tuesday, folks. So we don't have too much in terms of new content from Chapter 8. We're only going to do the first two out of three here, the correctness and robustness. We're going to skip efficiency. You'll come back to that in the later classes if you continue on. That's more of a data structures and algorithms class sort of topic. So it's okay. Feel free to read it if you're interested, but we'll skip over it. And then after we talk about the stuff from Chapter 8, we'll spend a little bit more time talking about GUI things. I want to show you an example layout, just an example. You are welcome to use it if you like it. You're welcome to ignore it if you like to do your own thing. Perfectly fine for the final project. I just want to give you an idea of what it might look like. What?
It's just an example, not what we're going to have to do.
It's just an example. Yep. And it's ugly, but it'll get the job done. Which is what we're looking for is function, not form. Right? You can continue on and learn all about making stuff pretty and usable, and we just want to get some function going here for the final project. And then next week we'll do more GUI programming stuff. Look at some other items, other fun things we can look at. Working with classes in there, using radio buttons and other checkboxes and all sorts of other fun things that are not just a button to click on. So there's other sorts of events and things we can do when we click stuff. With that, it should be a lot of fun, and then have more project work time. And then 418 is just final project work time. So I'll come in. I've got nothing to show up front. There's no stream. It's just you working on the project. And if you can get it done by then, fantastic, because I know you have other things going on in your life, other classes, whatever, so you can focus on their finals. If not, it's okay. It's not due until you present on 425, where you folks will all take a turn going. I'll set up a Zoom call for anyone who wants to be remote for that. We won't stream it. We'll just be on Zoom so they can screen share. And then you can show off your final project game. And we'll all play the game. It gets really boring after you've seen like 3, 4, 5, 6 of them, but it is pretty interesting because generally people try and make it work a little differently, or they lay out the screen a little bit differently, or they have a little different take on it, which is really fun. Not just here's the minimum spec I'm going to show you, and that's okay. If you just do the minimum, there's nothing wrong with that. But it's really interesting to see how other people kind of take it other directions or work with their layouts other ways. And we'll present.
Can you go again through the project, because I was reading it, but I was trying to read the idea.
Yeah, we'll talk about it some more. Yep.
Just like explain a little bit more.
Yeah, we'll talk more about the final project. So I want to do Chapter 8 stuff, and then we'll get into the project and looking at the layout for it as a sample layout. We can explain it then. Does that sound good? So there's no real lab to cover tonight. It was just making sure your JavaFX stuff worked. All you had to do was say that it worked for the submission. So if it didn't work, hopefully you told me it didn't work, and we can get it working for you.
Again, sorry.
For JavaFX?
Yes.
Yeah.
So for me to work, I had to go to run any configuration and add a VM option.
You shouldn't have to do any of that. So
It wasn't working.
We'll take a look and see. So all of that should be automatic when you tell it it's a JavaFX project. If you don't do a JavaFX project, you have to do all that extra junk.
Oh, I don't know. I was trying to do it first. So
yeah, well, we can take a look after and see. Because it should just start and make a project and go. Like it shouldn't need any other tweaks anywhere.
I was doing it the same way you did it. As soon as I closed the whole project, the whole IntelliJ, and I tried to reopen, it gives me like an error that you cannot find the Java effect.
I wonder if you're not opening the same thing then. We can look and see. Do you have a laptop with you, or okay? Yeah, we'll take a look at your laptop and see. Yeah, just starting a new project and telling it it's the JavaFX type here ought to be enough. Now, I did run into some trouble on these lab computers with version 20 of the JDK. So version 19 is what we started with because that's what was out. Version 20 got released at some point during the semester. I don't even know when. We could go Google it. And it didn't seem to work, but switching back to 19 seemed to be fine for everybody. So I haven't figured out exactly what it was yet, but just use 19 and we'll be fine here. You make your project, you create it.
Well, all you gotta do is to add library, add the two plugins.
So you want to install the FXML Manager plugin. So in File and Settings, so this isn't even to get the lab working. It just is helpful for you. If you go to Plugins and find the FXML Manager, we'll want to install that one. So that way we can open in Scene Builder and do the right-click to update controller. That's the only plugin there, and then you'll want to install Scene Builder.
Well, you have to add a library from
You shouldn't have to. The JavaFX project type should do all that for you, so they should already be here. All the JavaFX stuff. So if you had to add it manually, something was wrong for sure.
Yeah, I did it manually.
Okay, yeah, we'll take a look. The manual way works. It's okay, but it's slow. There's nothing wrong with it. It's nice when the tool does it for you. And it should get up and running. So we should get our hello world.
Yeah.
Yep, that's it. So if that works, awesome. We can work on JavaFX projects. Just want to make sure that was working for folks, so that you don't tell me the last week here that it never worked for you. Manually opening in Scene Builder. Yeah, so if it doesn't find Scene Builder, you can go set the path for it. So when you right click this, if you don't have an open in Scene Builder, or if it fails here when you try and open in Scene Builder, you can go change the path. So you can go to File and your settings, and you look at was it Languages, JavaFX, and you can say this is where the Scene Builder executable is. And it usually likes to install in this app data local folder. Just go find your shortcut and look at it. That's fine. Wherever it installed, we just need to go tell it where it is, so you can open in Scene Builder. And even if that's failing for you, you can go from Scene Builder and open the JavaFX XML file. It's just slow to do it that way. So you can say, hey, I want to open, my goodness, not recent, open, there we go. And go find it in Documents. Mine's in GitHub, 1500. This was, what do we call this? This is just demo, right? So demo, source, main, resources, example, demo. Here's the FXML file. So I can open it by hand in Scene Builder and work on it and add other things to it here. It's just this one's really slow to do. So I go add another button here. Click me or something. Right, that will go and update, and then I'm saving. Right, you'll see the little blue bar when you save. That'll update your FXML file here as well. So now you'll see. Where's my other button? Did I not open the right one? Thought I did. 1500 demo source main. Oh goodness. Should be another button now. Oh, I didn't give it a name. Is that why? Button. Yeah, no, here's my, okay, it's here. It's my click me button. Just wasn't tabbed in the same, I'm sorry. So you see the button was added here. And then if I go and run it, I'll have the other button. So lots of different ways to get it done. I'm just a fan of the easy ways here. So it doesn't do anything because we didn't add an event handler to it. But we could. All right, so let me close this down. And actually, let's go open up our shop project here. Because we want to look at what would happen if there's some issues in our shop, right? When we were running this one here. We're trying to get our, let's see. So we got an item name, item quantity, item price, add item, lookup item by name, update item, do these sorts of things. So to work with our shop that we're working on for the project. What we don't have, though, is robustness, which is such a fun word here. So in Chapter 8, talk about correctness and robustness. Again, we'll get to efficiency in another class. Not too big of a deal right now. So correctness is obviously important. We've talked about unit tests. That's one way to ensure we have correctness, that it does what it's supposed to do. That's my preferred approach. There's lots of other ways to test and some other things. So you can read through. He's got some fun stuff in here. Some people are really fond of these preconditions and post-conditions. I personally am not super fond of them. Not that there's anything bad with them, but it feels silly to me to write it down. But doesn't mean that they're not useful. So the idea is what is true before this method runs, and what is true after the method runs. That's our whole fancy way of saying it here. So there's a precondition and a post-condition. So if you're going to do something like find the discriminant to find the x-intercepts in a quadratic formula, right? Remember your formula, x equals negative b plus or minus the square root of b squared minus 4ac, both divided by 2a. I don't know why this is in my head. I learned a song in middle school, and it's been in my head ever since. So something about like music and brains is super weird. I don't know how any of that works. But it was apparently some school's fight song. But I'm really bad at music, and I don't know. But I still remember it. So for this to work, though, right, your discriminant has to be a real number because you're taking the square root of it. It can't be a negative number. Right? So for something to be true, if you want to compute the x-intercepts, a precondition is your discriminant is a positive number. Right? Without that being true, everything else falls apart. It just can't work. And then we get as a postcondition, so this idea as a precondition, is that a is also not 0. Right? Your the quadratic portion of it, x squared, whatever that x is not 0. Otherwise, it's not a quadratic. Right? So not 0, right? And that the discriminant is greater than or equal to 0. I guess 0 is okay, right? And then it's true. And then the solution is the postcondition. We now have set what x is when the method is done. That's the postcondition. So what has to be true before it runs, and what's true after it runs? I think some of this happens automatically, but it's nice to think about what has to be true for these things to run for our programs. So there's nothing wrong with these. Again, generally people do them like in comments, and I find that annoying here. So where does he has like a block in here? I don't remember where that is. Maybe he doesn't. He just talks about it, so that's nice. Yeah. So correctness. Yeah. Here, put a comment in. Your postcondition. The next character in the input is an end of line or non-blank character. It's nice. So it's telling you what will happen after this run. So the skip blanks method, if you just read this in English and don't look at any code here, this sort you get a feel for what it's doing. And here's your nice English version of what it's supposed to do. Right? When this is done, the next character in the input is the end of line or a non-blank character. We're skipping blanks. Then if we want, we can go and read and see what the code's doing. So it looks at what the character is. If it's a space or a tab, then it goes and gets the character and looks at the next one. Yeah.
Are these like unit tests where they have like their own class we do them in, or can you like do it in main?
So this is just a comment about what should be true before it runs and what is true after it runs. That's all pre and post conditions are. So we could code them as unit tests. And that's generally what we do with the arrange, act, and assert form. We arrange what we need to set up the precondition, we act on it, and then we assert that the post condition is true. So again, that's why that's my preferred approach. And then we have code that we can run and verify, and the computer looks to make sure it did what it's supposed to do, rather than us saying something and then, now we still have to go test it, rather than we could just go write some tests for it ourselves. That's sort of why. So he talks about the text IO library that he wrote, having some methods to do things. That's all well and good. That's fine. We're going to look at how to do the sort of error handling that he does later on. So correctness is important. We need to know, and if you can't really like say what the precondition, the postconditions are, you probably don't understand what you're doing in the code anyway. So generally, you know these sorts of things, and then they do it. So when we were doing some of that sanity checking, what I like to call it, like, hey, when you go set a length on something, the precondition is the length you're giving me is positive number. I'm not accepting a length of 0 or a negative number for length. It just doesn't make sense. Right? So that would be a precondition for our method, is that the value given is not less than 0, and the postcondition then is it's set to the right value. Right? Then we can sort of just identify what these are for us here. We kind of talk through it as we go rather than putting it in comments here. All right, so that's the idea of correctness. Right? We want to make sure our code's correct. And he's got some classic examples here in section 1. 1985, this was actually before I was born. I'm not that old, but real close, 87. A person was killed and several were injured by excess radiation because of, I think this was Therac 25, 15? I think it was Therac 25. Yeah, that sounds right. Yeah, 6 accidents. So the software allowed you to bypass controls of how much radiation you're supposed to give in this device for reasons, lots of stuff. You can go read all about it here. I think it was a design flaw, essentially. Let's see. 2 software faults were to be blamed. One, when the operator incorrectly selected X-ray mode before quickly changing to electron mode. which allowed the electron beam to be set for X-ray mode without the X-ray target being in place. I don't know what that means, but it sounds bad. And a second fault allowed the electron beam to activate during field light mode, during which no beam scanner was active or target was in place. That one sounds real bad. So if it's not correct, depending on your application, bad things can happen. I think I mentioned before, I've got this little device in my pocket here. This is my insulin pump. If the software on this goes bad, it will literally kill me. So I am very happy that it goes through all sorts of FDA approvals and regulations and checks and sorts of things before they mess with that software. The downside is the app on my phone now says, please don't auto-update your phone because we don't know if it works with your phone. I'm like, you can use your phone now to trigger the pump to do things when it's connected. But if you update, then it's no longer FDA approved because they have to test on every single model of phone. I don't know what their lab lists look like to have every single Android device out there that they test with. Seems like nonsense, but not killing people is a good thing. I think we can kind of agree on that. So you gotta make sure correctness is important. This one here, I feel like this was in a movie. Destroying records of an ongoing security transaction because of an error in a program. They were out $5 million in overnight interest payments on funds that had to borrow to cover the problem. Sounds messy. I guess that's not exactly the scraping fractional pennies theme of a popular movie. You guys did you guys actually watch Office Space, or are you too young for that? Not a classic movie people want? Oh, man. Okay. It's a good movie. Programming of the guidance system on the F-16 fighter plane would have turned the plane upside down when it crossed the equator. What? Wow. That one sounds like fun. Error in one line of a program. The Gemini 5 space capsule missed a scheduled landing by 100 miles because the program forgot to take into account the rotation of the Earth. And that's not a code issue. That's just we did it badly. But doing the right thing is important, right? In 1990, the long-distance telephone service was disrupted. Interesting. All right, anyway, so bad stuff can happen. So correctness is important. Testing it's important, that sort of thing. Then what do we do for robustness? Robustness is not crashing, right? Which we don't have that right now. So if I enter, hey, I want to sell, phones for $10. Quantity 10, item price. The phones are crazy expensive nowadays, right? Let's do $999 and add it. Nothing's happening right now, but behind the scenes, we're getting all these exceptions. Bad stuff's happening, right? And we're not telling the user anything. We haven't done anything about it here. So this is not a very friendly program. So the user probably thinks they added it to the inventory, and we go look it up, and now it's not found, and we're sad. What's going on here? So what we want to do is figure out how we handle these exceptions. Now, not only can we handle these number format exceptions when I get input in a form that I don't like, but I can also handle things like my file IO exceptions that previously we just said, hey, we're just going to pass the buck. I don't need to do anything about it here. I'll just crash, which is really sad. You don't want to just crash. You want to be robust and handle that. So what we can do when we try and parse a value here, we can catch an exception. So the form that you use is you put it in a try and catch block. So the idea with exceptions is there's all sorts of interesting exceptions, and they use inheritance here. So everything is throwable, and then there are errors, which are the really bad things. Pretty much everything we've seen is an exception. There are runtime exceptions, which while the program is running, this exception might happen. Right? You might give me an illegal argument, you might give me a number format, you might get an array index out of bounds. These are runtime exceptions. They can just happen and we crash. The other types of exceptions are checked exceptions that it won't let us compile unless we handle it or tell Java we're okay crashing. So it's hard for Java to handle this array index out of bounds exception when you have a variable and you say, hey, I want to make an array of length something, and that's a variable length. Java has no way of checking any of that because it just says, hey, you have an array, I'm whatever variable size you told me. It can't know when we compile. And we're not going to make every program handle a possible array index out of bounds exception because usually we deal with them. But with things like IO exceptions, things that are checked exceptions, Java says, hey, a bad thing could happen, you need to go handle it. So in our case, what we did for our shop here is we just said, hey, we throws IO exception. I'm not going to handle anything. I'm just going to crash, which is not what we want to do. We want to do better than this. So to do that, we use a try and catch block. So you're going to try something that might cause an exception, and if an exception is thrown, you catch it. So it uses this idea of you throw things and you catch things, right? I think that's sports ball. You throw and catch things a lot. So if an exception is thrown, we can catch it. Now, what's fun here is as soon as the exception happens, the rest of the code in the try block stops. It doesn't run. So it's like an immediate break and jumps right to the catch block, which probably makes sense because it should not be able to keep going if this thing didn't work, because we probably depend on that thing working here. So what we do in our code here, let me close that down, is we're going to wrap this in a try block. Let's see, it's in here. So we're going to try to do this thing to make an item. And then what we're going to do is we're going to catch. And you can catch specific exceptions, or you can catch more general exception. Remember, this idea with inheritance is you are a kind of your parent class. So you can catch the general exception here. That's usually considered bad form, right? So generally we try not to just catch the general exception. Catch exception. Sometimes we'll do it anyway, but yeah, let me put that in the right spot here. So we don't want to just catch exception. So we want to catch, so this specifically here then is a number format exception, because I know, hey, what failed was this number format exception. So I can catch this specific type here. And then we give it a name. So this exception is an instance of the number format exception class, and it has all sorts of interesting details. So for us, I think we had a label, right? Do we have an error label? So we can take our error label, we can set text, exception to string. So we'll take the exception, turn it into a string, and set the text on our error label. Let's see what it is here when it crashes. Now, the rest of this isn't going to work, though, right, if that item doesn't exist. So you can put more things in the try block here, which is this idea. So if this fails, you can't continue because there is no item. So as soon as this exception happens, it'll jump to the catch block. We'll do the catch thing. Great. That's what we want to have happen. If it works, then we just keep on going to the next line, the next line, and the next line, and the next line, right, which is what we want to have happen here. So now if I can't parse the integer for quantity, and I can't parse the double for text price, then we should get that exception message. Oh, this was my update item button. Oops, I got to do this in the other one too. So that was update item. We want to try it in add item. Here we go. So one more try catch. All right. So try all these things, and then we will catch the number format exception. I like calling it EX for exception. Some people just put E for exception. I don't. It really doesn't. It's just a variable name. It doesn't really matter here. I don't feel the need to explicitly write out number format exception. That's one of the rare cases that I use like an abbreviation here, because the only thing we usually do with it is just you grab it to string here. That's our error label, set text, my exception to string. All right, now let me try that one more time. So I got it both on add and update. So we wanted what, phones, 10 of them for $9.99. Let's add the item, and now we get Java lang number format exception for input string 10. Now this error message is actually not very friendly. This is probably useful for people who are developers. We can understand what it means. So we don't have to just take the exception message and spit it out there, right? Not necessary. Now it's nice that we're telling them 10 here, but number format exception is not super useful. So some kind of combination of giving them a message and giving them another error might be useful. Or sometimes you give the nice English error message and then you've got like the detailed garbage that's like, something went wrong, please give this to your system administrator. And that's where they get the garbage error message that means nothing to most people. It's just a style preference. Whatever we want to do here is perfectly fine. So maybe we can put a little message in here. So we'll set the text to unable to read quantity or price. And then maybe a new line here, right? Because we got in labels, you have to add your own new lines. So let's do this here. Oh, now we don't need the toString because we're concatenating, but that's fine. We'll leave it in. And then we can set this over here as well. Okay, just to give a nicer error message, so they kind of have something useful that's easy to read here. Apples and 10 and 123 or something. unable to quantity or price. Now we didn't tell them which. If you wanted to get very specific, we could try parse on quantity, or we could separately try parse on price. That's great. You'll give them even more details. And really you want to validate each and every field, and there's ways to do that. We're just not going to get into it. That's a lot of work. If you can do it once, I assume you can do it 15 times if you have 15 different inputs. That's just kind of a waste of our time, right? Is that fair to say? Okay, so we're going to do the lazy thing, because if you can do it once, you can do it. We just don't need to, okay? So we can handle that exception. Now, other exceptions that can happen, though, right? We have other things that can happen, like in our shop class. We don't want to throw IO exception every time. What do we want to do instead? Well, maybe it's okay that this one throws an exception and we want to handle it somewhere else. So it kind of depends on what we want to have happen. And this is a little bit of how we design things. So if we want shop to do something here, when it can't write item file with whatever this IO exception is, when like this is, it can't open the file to write, we could make shop do something. We could. Maybe we don't want shop to do it though. Maybe we want it to throw the IO exception and have whoever asked shop to do it handle it. Because again, the idea, our shop class, we took completely just copy pasted from being a console-based application to being a graphical user interface application. If we tried to do something specific in the shop class, like printing out an error message in the console, you're not going to see it when you run the graphical user interface program. So that's not what we want to do. You don't want to always spit an error message to the console because there's no guarantee people are going to see it. So it's okay to throw an exception sometimes. What that means then is in our controller, anytime we try and do these things, we also need to handle those exceptions. So we make the shop and we get an item. Here, right, this get item method. Let's go to, so navigating around the files as you get more and more and more and more files and more classes can be a little tedious sometimes. So I'm a fan of shortcuts. So when you go to get item here, I can right click on it and say go to. I want to go to implementation. Will take me to the get item method where we're using it, right? Which is nice. So to get an item, it might throw a file not found exception. Ours should be fine here because we're checking to see if the file doesn't exist first and returning a null. Java doesn't know that though. So on our purposes, we're probably okay for this one. This was probably not going to say like bubble up. We're probably not going to get the exception from here because we checked to see if the file exists, right? If it wasn't found, then great, we return null. Not too big of a deal here. So this one's probably okay. Let's see, and our item, let's go back. Where was I here then? Back. So our item here, if it's not null, we set the text. So we're handling this one okay. So where else do we use shop where we might have trouble here? When we go and add an item. So shop add item, if we go to implementation here. This one might throw an IO exception because writing a file could possibly fail. Right? This is something that's prone to errors here. Permissions issues cause issues sometimes, depending on where the program is running. If they're trying to run it off of a network location, weird stuff can happen. Files are a little messy sometimes. They don't just always work, which is a little bit unfortunate. I mean, usually they do, but they don't always. So this one would make sense to have a try catch for. So I'm going to go back. I've got a back button on my mouse, and that's been really handy. I don't know where the actual back button is. Navigate. You can go navigate back. I think it's probably what I'm doing here, just to get back to where I was. So we want to put this in a try block here, right? So it should be telling us if it wasn't able to add here, right? Because we're giving a Boolean value, true or false. But that was just whether or not the item already existed or not, whether not it failed to write. So we can handle that with another try catch block. So we can say, hey, let's try this here. Try all of this stuff here. Oh, but now we have a try inside of a try. Well, that's okay. It works. So this time we're going to catch a, what was it, our file not found? Or no, my goodness, I forgot already. IO except, just an IO exception. So we'll catch an IO exception. And then we'll take our error label, set text. I don't know. For now, let's just put the error to string. I don't know exactly what we're going to get here. So it's okay. I did the format, the format code, Control-Alt-L. To reformat that, it'll fix all the tabbing for you. So we have a try inside of a try. So the first one we'll try for the parsing, and then we're going to try for the adding item here. right? And if that one fails, then we get a message. If the number parsing fails, we get a message. Now you can combine them into a single catch here in a single try block, but like with our error messages here, then unable to read quantity or price is not correct because it would have been an IO exception possibly. So we could check to see what type it is. I don't know, that feels kind of messy too. Having a try inside of a try might be a little ugly. Let's do the alternate approach then for the other one then. So when we go update an item here, update item has to update the item. So this possibly then will also throw that exception, right? If we go to our implementation, this could throw an IO exception. So let's look at with a single try block here then. So I could say a number format exception or a IO exception. It's weird it's a single pipe here for OR instead of the double pipe. This is technically the correct OR. The double pipe is the short circuiting OR that says as soon as I find one that's true, I just stop looking at all the rest. So we generally always use the short circuiting one because it saves operations. But this is also an OR. This is number format exception, or IO exception, right? Then I don't really want this message here, so I can say, hey, if my exception, this one is ugly here. So if it equals, I don't want if it equals another one. Get class equals IO exception. Oh, that's not it. Dot class. This is really ugly. This isn't going to make any sense till next class here. You can ask the exception what its class is, and you can compare that with the class definitions class. Don't worry too much about it. I just wanted to show you can do this as an OR here. So if it's the IO exception, we'll just spit out the exception to string in the error label. If it's not that, then right, it must be our other one here. Just we can do this in an else. We'll take that. Okay, so if it is a number format, we don't say unable to read quantity or price. So just two different approaches for that on how we can handle the ORs. I think that's okay. So our lookup item was going to be fine. Add an update, then we fixed with our try block. So I think we're in pretty good shape here in terms of dealing with the exceptions here that could happen in our shop class. And it's okay that shop throws exceptions, right? This is a way for a class to communicate with whoever's using the class that a bad thing happened. It doesn't make sense for the class to handle it all the time itself. So something like item here, if we wanted to have a set price then and do a sanity check on price, we can say, hey, if my price is less than 0, or maybe even equals 0, because you probably don't want a price of 0, right? Because I don't think you want to give things, maybe giving things away for free is fine. So maybe also a negative. We could give it away for free, but we can't give money to someone for taking this product, right? So if price is less than 0, what would we have done before? The only thing we've looked at is like we can return a true or false value. It's just kind of tedious, and then we don't actually know that the person using our code is going to do anything with it. Will they even look at the Boolean value true or false to know if anything happened? So it's not an ideal approach. It's one way of approaching it, but now we have the option to throw our own exception. So we can say, hey, when you set the price, if you have a price less than 0, I'm going to throw a new, argument? Illegal argument exception. We can say price cannot be less than 0. So we can throw our own argument, which will cause whoever called the setPrice method to either handle it or crash. This illegal argument exception is a runtime exception. Right? At runtime, it will either crash on them or they'll have to handle it in their own try-catch block. So anywhere we're using setPrice, then we'll need to make sure we're trying and catching. So let's see, in our good sanity checking, right? We already wrote the code once. I don't want to write it again here. So instead of saying we'll just take the price in the constructor, we'll use that same setPrice method here, right? Which will also then throw the exception for illegal argument if it's bad. So the sanity checking that we're doing here is saying, hey, it's just not going to go. I'm going to throw an exception. You have to deal with it or crash. And at this point, you won't have a default. So if you give me a bad value for setPrice, price never gets changed. We don't say, oh, I'll just assume it's 0, like we did. I think it was with the car example. We said, hey, we'll just set the fuel to max, right? Or do we not even add any fuel? I forget what we did with that one. With the cup, we stopped at the top. One of them we said, hey, you stop at the top or you stop at 0, right? I think we did that. In this case, we're just going to throw the exception and say, you deal with it. Try again. Right, so when we're making our items then in shop, let's see, shop makes items. Now our default here is 0. So it's a good thing we didn't do 0, otherwise this would have caused an exception for us. Less than 0 was our issue, or our concern there. Let's see, so we made items. So in the hello controller, when we make an item, we'll also then have to deal with the argument exception, because maybe they updated my price to negative, or we crash. So before we deal with that here, let's see, so we've got, let's look up item by name. Let's look up apples. I think we've got an apples here. If I want to update the price to -1 and update the item, we get an illegal argument exception. So the exception is being thrown here. We're not catching it. So we're not exactly crashing, but bad stuff is happening behind the scenes, which is no good. So we want to handle that. So right now we're only catching number format and IO exception. We say, okay, let's handle number format or IO exception or my illegal argument exception. Handle all of these. So now we have a couple different cases, right? So this is else the illegal argument exception class. Let's see. No, else if. Oh my goodness, I can't type here. It's been a long night already. It's not even 7 yet. My goodness, definitely needs more Coke. So we'll say, okay, if it's IO exception, put it to string. If it's this one, so if we're doing the same thing, that's kind of silly then, right? We could just do an or here, or this. That's probably a little better here. Yeah, then we don't need this else if. Does that make sense? We can just kind of clean that up. Because if all we're doing is setting the label here, we're okay. Number format. Oh, interesting. So number format is a subclass of the illegal argument exception. This fancy disjoint is a fancy term because it is one of these here. So we don't even need to include number format then. So we can have, oh, that's going to be ugly now then though. If this is an illegal argument exception. Okay, I think we'll be okay if it's a number format. We'll try it. Try it and see. Again, doing the ors here is a little bit ugly rather than a couple different tries, but probably okay. So let's try apples. Look it up by name. Update price to -1. Okay, illegal argument exception, price cannot be less than 0. That's a good sign. And now if I say like 10 here and I try and update, now we get unable to read quantity or price. Okay, so I think it's working out okay so far for us. That's what we expected to have happen. So we can get our 2 different messages. Price cannot be less than 0. Cool, so we get a nice message here. So notice this message is what we gave the exception. So when we said, hey, our item here will have this string here for legal argument exception, that's the message that came through when you printed that exception to string. So like I don't know, we don't say here the string here is part of the exception message. Does that make sense? Message display shown when you to string it. All right, I feel like today's really boring. I'm sorry. So it's important stuff. So this is like the right way to handle dealing with, so not only protecting the integrity of our class, right, by throwing an exception, because just returning a true or false is not super useful. I mean, we're still doing something. We're still making sure we have valid values, but it doesn't force anything to happen. Where throwing an exception forces the caller to either handle it or crash, and no one wants the program to crash. So it's nice. It's a nice way to communicate with whoever's calling the code here, because I don't want to just spit a message to the console that might be ignored. I don't know if there's a little text label or something I can set on a screen here. I don't know if there's something I can do on a website. Right? I don't know what UI is being used, but the class itself will communicate with the caller of the class, whoever's using item then, and now it's up to them to deal with their legal argument exception, to handle it or crash, and deal with all of these. All right, that makes sense? You feeling okay? All right. Let's see. So that's the try. You can have 2 different catches. Right? You can catch and then you can catch. That's what we were doing Oh no, we just oh my goodness, yeah, okay, so this is catching a specific exception, catching a less specific. That's even easier. Okay, that's a better way of doing that. My goodness. That's what I get for not reading the chapter. Like I did it like an hour, 2 hours ago, and I already forgot. So catching this way you can, or we could do the same thing then. We could write this as I want to, let's do a catch for number format exception. So specifically, if it's a number format exception, we'll do this one here. If it's not a number format exception, then we'll catch it if it's an IO exception or a legal argument exception and deal with this way here. So in this case, this else is redundant here. This part will never run here, because we only had the number format exception or IO exception or legal argument exception, right? The only other type was number format, which would have been caught above. So they go in order. So you want to do the specific type. So because number format is a type of a legal argument, if we catch it first, we'll handle it first. If it's not that, we'll possibly catch it in the next catch block. And you can have a gazillion catch blocks if you want. And through the amazingness of inheritance, we can say, hey, if I want, I can even write a new class here. This is my custom, we'll just call it a legal price argument exception. And this can extend the legal argument exception. So I can make my own exception that adds itself to the exception hierarchy, that inheritance. And then I can throw an illegal price argument exception if I really wanted it here. But for this, you need a public illegal argument exception, takes a string for the message, and we'll just call our superclass and give it the message. That's all we need. So it doesn't need any logic. All it needs to do is extend an exception type. And then if you want to be able to pass the message up, like we put in a string message, you just call the superclass and give it that string message. This will pass the message to the parent class and to, I don't know, track or something, but we don't need to track it separately. So then in my, and now it even gives it a cool lightning bolt icon. Look at that. It knows it's an exception class. That is so cute. Super cool. So an item then, instead of throwing a legal argument exception, we can throw in a legal price argument exception. Sure, why not? Now in my hello controller, I could catch the illegal price argument exception. Nope. Sorry, that's the number format. That was the wrong one. This one over here. Illegal price argument exception here. And really, we're doing the same thing one way or the other here. This one doesn't matter too much here. So I'll just, that's fine. We'll leave it in here. So illegal price argument exception. I'm trying to keep all those different examples in so you can see them. So if you give it an illegal price, let's look up apples again here. Look at my price, and we give it -1. Go to update. Illegal price argument exception. So we get the name of the class here. This is com example week 12 shop. So the name of the class that shows up in the message is our custom one here that we did, which is fun. So you can make custom exceptions, and you can make custom exceptions that inherit from your custom exceptions, and custom exceptions that inherit from the custom exceptions that as far as you want to go, right? Go nuts. I like to just stick with the legal argument exception for things that are illegal arguments. If you gave me a bad value, and it's an invalid value for my class here, I'll say it's an illegal argument. If you want to get specific, you can. You're welcome to do it, but we didn't really gain a whole lot out of doing it. It was just kind of fun at that point here. So other things like null pointer exceptions are problems. Right? If something is null and we try and use it, it might crash on us. That's what we did all this checking here for. If it is not null, or if it is null, do something. Because if you try and use item dot and an item is null, it will crash on you. You can handle it with an exception. This is generally considered better form because dealing with an exception is technically slow. Now, for our purposes, it happens super fast. But if you can avoid handling an exception, it generally will perform better, especially for things that you do a lot of, because that exception handling has to do a bunch of interesting stuff behind the scenes in Java because remember, Java tracks where we are. It says, hey, I was at this method in main, this line in main, and then I called this method over here, and I'm at line 27, and here's my variables, and then I had to call a method over here in this class, and I'm at line 13. It has to track all of that, and when an exception happens, it has to pause all of what it's doing there and figure out where it's going to get caught, and have to go look back. Did it get caught here? 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 And if it gets all the way back to main, it wasn't caught, it crashes. Right? So it's not the fastest thing in the world to deal with that. So I wouldn't recommend using the null pointer exception catch, but you could if you wanted, right? You can do all sorts of fun things if you want with these. So, and then the last thing you can do with the try catch block is you can have a finally block. So what happens with finally is it will run whether or not the try ran or the catch ran. For us, not all that useful. There's not really a whole lot of things here, but what happens often is when you're dealing with network connections, bad things could happen, but you still need to close the connection. So I can't say, hey, just like a file, I want to open the file, I want to rewrite the file, I want to close the file. If you're dealing with network connections, once you open it, if a bad thing happens and you forget to close it, it's no good, right? Bad stuff will happen. You can't use that connection again, and it causes all sorts of trouble. So if an exception happens, because things happen over the network, right? I missed this message, or something bad happened, or I lost my connection, whatever. Eventually, we'll go and close it in the finally block. So it's useful for that sort of thing. Or if you want to give default values, we could do that as well. We could say, hey, I'm going to try, let's see, I think we had a try in here somewhere, right? For an item, did we do a try? Where did we do a try? So if we wanted, none of those are any good here. Bless you. Yeah, none of these are great for a finally block for us. But you could set a value inside the try, and if you get to the finally block, it's not even great. No, we're probably not going to use it. Later on, you might have more advanced cases. So keep it out there. Just know you can add a finally block that will always run at the end here. Yeah, like clearing up resources. And then some fun syntax. You can use a initialize inside of a try with the set of parentheses here. This is fun. So it'll automatically make sure that it gets closed when you're done. When you close the scanner, right, to close. We haven't done it before, right? For standard input, you're supposed to close it. It's the right thing to do, but we just never bother. So you can put a statement in like, hey, I want to try this here, and it'll automatically close it when it's done. So it's kind of a shortcut to using finally. And then, yeah, writing our own exceptions. We can say we throw a legal argument exception. So we can specify that this method will do an exception here. So in my item here, we can say set price throws a legal price argument exception. To be specific, so when someone goes to use this, they're going to see that this could happen. So this is a nice to do thing here. So as we're using set price here, so if I go to my item, I'll just add a line. So if I go item set price, is it going to give it to me? Where's the? So now when I look at set price, you see how it says throws a legal price argument exception, because we added that note when we call set price. If you don't have that in here and you just throw it, set price, I don't know, 1 or something, it doesn't say it. So it's a nice habit to get into, that if your method's going to throw an exception, you should put it in there so that way people will see it in this IntelliSense. Right? So I'm going to put that back in here because it's helpful. So it's just like you see the variable names. You see the full variable names when we're saying, hey, I want item dot a set price given a price, set quantity given a quantity, instead of P and Q. Right? We give good names here. We just give good information when we're doing these things here. It's useful. Not required, but it's a useful thing there. And then these ideas of the mandatory exception handling or checked exceptions, right? All the Iowa stuff, Java wouldn't even let us compile because it knew a bad thing could happen. We had to tell it we're going to handle it or pass the buck and crash. So it's up to us. All right, awesome. So that is what we want to do. The assertions and annotations, we've done the annotations, right, with this add override. I think we talked about that one already. Don't worry about that. And then assertions, some people love these. I'm not fond of them at all. And assert is basically like an illegal argument exception. but you have to do a bunch of extra work to use it. And I think that's just dumb. You can like say, hey, I want to assert A does not equal 0. Here's the message, rather than throw an illegal argument exception saying can't be 0. I don't know. Some people love them, but you have to do like all this extra stuff to enable assertions. That seems silly. So we'll just use exceptions. All right, so why don't we take a break? We'll come back. We'll do some more JavaFX stuff. We'll take a look at the project again, look at what a layout might look like. I know some people have some questions about the 2D array for rooms. We can talk a little bit about that as well. A lot of people are just wondering how to even start. So we'll kind of talk about how we take a big problem and break it down into small steps. That's the idea. We're going to do one small step at a time, and you can solve one small step at a time and get it running, and then add the next piece, and then add the next piece, and add the next piece. And that's sort of that iterative development process. You don't need to write it all once and then finally click run. You got to write a little bit and run it, write a little bit and run it, write a little bit and run it. Okay? All right, so why don't we take 10, and then we'll come back in a little bit and pick it up from there. Oh, goodness, sorry. I wasn't paying attention to chat. I'm sorry. Thanks, guys. I was on mute for a little while. This is what I get for muting. I did that last time too. It did work. Did you just follow and unfollow or something? I heard the bing. Thank you. All right. So we're looking at the different layouts. You can only have one thing inside of a spot, which is unfortunate. So, like an array, though, the thing that you put inside of it can be another array. That's how we made our two-dimensional arrays, right? So you aren't necessarily stuck with just one. So instead of just doing up, down, left, and right here, what I can do is I can do another container. You could put an anchor pane in there. You could put other things. A fun one here that I kind of like, where is it here, is the grid pane. So I'm going to do a grid pane over here. And the grid pane says, I'm going to build a grid, so many rows and so many columns, and every row and column is a spot to put something. So I'm going to add a couple rows and columns here. Let's see, we want to how do I add row? No, I want a column. I want to add some columns, add some columns, add some columns, add some columns. Okay, so I'm going to add a bunch of columns here. Now I could put some buttons in here at specific locations. So I have a button here, a button here, I have a button here, and a button here. Oh my goodness, click the right button. There we go. And then it might be nice if these were like centered a little better. So let's do our horizontal, horizontal alignment with center. Horizontal alignment center, horizontal alignment center, horizontal alignment center. To center them all. And now my buttons, I can change this to be up, down, left, and right. Okay. If I want to do with anything with these in code, I need to go give them names, right? You need these FX IDs. Here's my up button. Here's my left button. Here's my right button. And here is the down button. Right. So now I have something here. Now I can add some on action events, right? This is my up button clicked. Here I can have a down button clicked, a right button clicked, right button clicked. Right, we can add some event handlers if you wanted here. Down button clicked, and a left button clicked. Super exciting to build out UIs, but that's okay. We'll get there. Right, so now I've got some navigation buttons. Right, this idea I can navigate around my maze. Cool. I can do something like that. And then maybe over on the left side, then I might have just a label. And maybe this label then is my player stats or something. Player stats. And we give it a name, right? An FX ID. It's going to be my player stats. Player stats label. And then over on the right, we can do a similar thing for NPC. Where's my goodness, label. Can't see things. Label. So we'll call this our NPC stats label. And we can check our properties. We'll call this NPC stats. And again, you can do any sort of alignment that makes sense for you. You could center align these things. Center align is usually pretty nice here. So where's our alignment? Oh, goodness. Alignment. It is center. Oh, I want top center? What's no. It's just center. Center right? I don't know. That's all right. It's not too big of a deal. We can always fix that later. All right, so we've got this information here, and then the game needs to like tell people stuff. So a common way of doing this, and again, this is just one approach here, is you can take a text. What is it here? Our text. Hang on, I'll find it here. Label, button, scroll bar, text area. There we go. Text area. If you drop a text area in the middle, text areas are cool because they will automatically scroll when you add text to them. So you can just start spitting stuff out here, like, welcome to the stupid game. You went up, you went down, you went left, you went right, you found a monster, you attacked, you got hit, you did this much damage, you ran away, you searched the room. All the things that you can do, we can just spit text out in here for. And then we don't have anything for the top yet, so maybe we'll add a label for the top. So if you can't find the top, you can always come over to this navigation section on the left. So let's call this one our, I don't know, location label or something. And again, you can go back and do different things with this if you want here. So here's our location label, and here's our text area. Cool. So then all of this, oh, we need some other buttons here, right? I forgot we had some other buttons here for like, what do we have? We wanted to center these, make these a little prettier. Layout, center. Maybe this is the, I don't know what, tack button. Tack. And if you want to put them in a group of 4, you can put them in a group of 4. Doesn't matter how you want to lay these out, right? Just different options. So run, sleep, and search or something, I think were our options here. And again, center them all, make them all pretty, however you want here. Is that a question? So when you go and grab a button and drag it in, you can put it anywhere in this grid that we built. So we put a grid inside of the lower section. So the border pane has a grid pane in the bottom section. Because a container can only have one thing inside of it in each of these sections. So if you want more than one thing, you have to put another container, because that is the one thing. That one thing can have a bunch of other things. So you can have containers inside of containers inside of containers inside of containers. Think of those cute little nesting dolls. They just keep popping open. Yeah. So you just put containers inside of containers. Inside of containers, you've got to hold multiple things. So for a single label, that's fine. We can put a single label here. But if we want a bunch of buttons around here, right, for managing all these things here, this is bothering me here. I'm going to go and make these all centered. Center, center. Probably could have done all that at once, but that's fine. So then we'll go ahead and save that. And then in my program, I'm going to come right-click this and say I want to update my controller from the fxml file. Oh, error. I forgot. Once you take out your first VBox, you have to go add the controller again. The error is not very helpful here. So tell it where the controller file is. Then you can go and update from controller, and it should work. There we go. So now we get our controller here, and we have a bunch of things. We got some buttons. Again, you get some red lines. That's fine. You do Alt-Enter, import. We got a text area. We got to import. We got action event. We got to import. Right. So we didn't add all the event handlers yet, but that's fine. And we don't have a on hello button clicked either. That's weird. Get rid of that one. All right. Let's try updating again. All right. So cool. So when you do something, how about if you click the up button? We'll take our text area, and you can append text. You clicked up. Is there a question?
How did you update your controller file when you had to add a new box that just from like your path files or your project located?
How did I up? I'm sorry, I'm missing when I updated.
You updated you had to update your controller since you added a new box.
Yeah, so I right-click the fxml file and say update controller from fxml.
Yeah, but when you had the error since you had the new box.
Oh, so to specify what the controller is, so usually you get this hierarchy view in the bottom left where you see this is the top level and what's inside of it, what's inside of it, what's inside of it. So underneath that is the controller section. So it says, hey, what's the class for the controller? You just go pick your controller class by hello controller or whatever you want to call it here.
So it would be in the actual code itself, the controller class?
So this is a class in our code called hello controller that says, hey, go use this one over here.
Okay.
Yep. It shows up in the fxml all the way to the right here of your fx controller.
Okay, so you copy that, paste that into the area.
It should just show up here. Like you click the drop down and it finds all the classes.
Okay.
Yep. Yep. So we're just going to append some text, right? When we click up, we'll just append text you clicked up, and let's see what happens here. So if you don't have the run to start, go to your hello application and do the little start here first. Then you should get the run button next. Sometimes it gets a little funny. And if I click up, we get, I'm just going off to the right, but I get a scroll bar off to the right. But so you got to add your own new lines. It's a little bit annoying when you go add these things. So usually I'll add a new line after I print everything. Because that way it will print and then it'll be ready for the next print to be going down a line. Anyway, actually let's do the rest of these here. So you go left, you go right, you go up, you go down. You click down, you click right, you clicked left. Okay, there we go. And let's restart. So now I should be able to go up and right and down. Oops, down, and left. And now the cool thing with the border pane is it auto does resize itself to a certain point. Certain items like just don't fit. So if you go too small, you get like nothing. But you can go bigger than that other size, and like it just kind of resizes with you, like the V box did originally for us too. It was kind of fun. You can just go navigate around and do some buttons. So this is an option for a layout for your final project game, right? The idea with the final project here, let me go open up Desire to Learn. And I think I got a bunch of your labs graded. Still working on the other stuff, but I think the labs should be in for you.
Yeah, they are.
Cool. Let me go look at Bad Adventure Game.
So when you press run or whatever, for example, yeah.
From Hello Application, you click Run here. It should.
So yeah, you run this and you go like, I was trying to like ask you for sleep, run, and stuff. About the goal, I don't understand like.
Yeah. So we'll talk about all that in a second. Yep. So building with JavaFX, we haven't got to this 2D list of arrays of rooms yet. We'll talk more about that later. We'll get to there. A class for room. We'll put a bunch of rooms. So if you just want to start with one room, that's great, right? Or don't start with any room. So you can just have just the player, just the NPC. But the idea is an NPC goes inside of rooms. So I can make this map here and say, hey, here's 100 rooms, 10 by 10. Random's the easy way to do it. Just randomly pick whether or not there's an NPC or not. Randomly pick if it's blocked or not. Randomly pick how much gold is in there. Perfectly fine. We're not making an interesting game. It doesn't have to make sense. Someone who's building an actual game that has like a story behind it would say, hey, this particular room has these attributes, this room has these attributes, and like you kind of make it part of the story. We don't need to do any of that. So we'll just start with just the room or just an NPC. The player character class, right, has all these attributes. So they have hit points, so start at 20. Every time you take damage, your hit points go down. If you get to 0, you're dead. Game over. Right, like most games. Your strength is 3 rolls of a 6-sided die. Again, that's not a random number 3 to 18. That's different. It's a random number 1 to 6 3 times added up. I promise it's different. Go take a stats class if you're interested. And then total gold, you start with no gold, and you just start picking up gold as we go from the rooms. So the rooms, there should be inside the room, yeah. Yep, you can set a random number here.
Everything is randomized.
Yep. So, like, ideally, there's like 1 in 2 chance. So 50-50 chance there'll be an NPC in the room. Again, you could just make every room have an NPC to start, or make every room have no NPC to start. However you want it to kind of start building it, it's fine. Then you can add in this random chance.
So, for example, you ask us for every direction we go, there should be 10 different ways.
Nope, it's just a grid, 10 by 10, and you can go up, down, left, or right in that grid. So like at 0, 0 in the top left, you can go down and you can go right. You can't go up because there's nothing above, and you can't go left because there's nothing to the left. You're in the corner, right? Once you go over and down, then you can go up, down, left, and right. Because then there's a room above you, a room below you, a room to the left of you, and a room to the right of you. Or I'm backwards of you, sorry. That was my right, your left. So that's what this maze, we're tracking this. So eventually, if you go to all 100 rooms, find all the gold in all 100 rooms, you're done. You know, a real game would have like, here's the next level of the dungeon, or now you leveled up and you get more stats and more weapon, like anything that makes a game actually interesting, not just we're just going to walk around. Oops, I clicked the wrong button here again. But it's game-like, kind of looks like a game, has some of the form of it, but it doesn't have to make a lot of sense here. So non-player characters are the things we fight here are basically the same idea, but they get their stats differently. Yeah?
So for like in the actual like Java FX application for like the search button, is it fine if we like just have it like you found the gold in the room and just search it?
To start, yeah. So later, there's specific requirements about how it should work later, right? And that's just a little bit here. Yeah, so non-player characters have stats. They don't have gold, but other than that, they have all the same stats. They just get different values here. So 1 to 6 instead of 20 hit points, and then double whatever that was for the other stats. So for searching the room, here's where you roll a 20-sided die. Pick a random number 1 to 20. If you roll less than your intelligence, you find the room in the gold. You find the gold in the room. So take the gold out of the room, right? Set the value in the room to get rid of it, and add it to the player. That way, once you've searched that room, you can't go search it again, right? You've already found all the gold in that room. You're not going to find any more. That's it. You took the gold. It's in your pocket. You're done. So eventually, you should be able to search all 100 rooms. And there's no rule against search. It would make sense that you have to like leave the room and come back to the room before you could search again, or any sort of thing. Interesting. We just, again, interesting is a that's the next step. We just want a little bit of function here. Hey, it's our first programming class. We just want to look something that we can click on that looks like it might be a game if we wanted to spend more time on it. Right? It wouldn't take too much more time to make it slightly interesting, but again, that's not the like interesting is not the goal. Just can you make this function here? So for fighting, if there's an NPC to fight, you can roll a 20-sided die. If you get greater than their dexterity, you hit them, which most of the time you'll hit them because their dexterity is between 2 and 12. Right? So you got a pretty good chance of hitting them here. When you hit them, they take your strength divided by 3 damage. You have at least 3 strength, right? Because you get 3 rolls of a 6-sided die. You just round it to a whole number. Integers are fine. We like integers. That makes life easy. They don't need to have a double amount of hit points. If you want, you can. That's perfectly fine, but it's probably more work than you need. And then if they're still alive, they have hit points left, then they get to attack us. Works the same way. They roll a 20-sided die. If it's greater than our dexterity, we get hit, and we take damage of their strength divided by 3, except at least 1 damage, because if their strength is 2, they should still do 1 point of damage. All the other, because they have strength of 2, 4, 6, 8, 10, 12, all the other ones should work just fine, but just minimum of 1 for that. So that's how we can attack an NPC. So we have to check, hey, is there an NPC in the room? You might get a null back if there is no NPC, right? Like we did with our item here, I might give you back a null. You need to check for that. So if room has an attribute for NPC, like shop had a get item by name, you might have the room might have a get NPC. It could return null, it could return an NPC. So you just have to check for that. To run away, so if there's a monster we don't want to fight it, we can run from it. So it gets to roll 20-sided die. If it rolls less than its intelligence, it notices us running away because these monsters are stupid or whatever here. It gets a chance to attack. So it'll roll a 20-sided die, see if it hits us, we'll take some damage. Sure. And then when you're doing the runaway, all sorts of different options are perfectly fine. It doesn't have to make sense. They could go back to the room they were in before. It's actually hard to do because then you have to track what room they used to be in. And every time they move to a new room, you have to update the room they used to be in. It's not the hardest thing in the world, but it takes a little bit of extra work. If you just want to move them in a random up, down, left, or right, great. If you just want to let them pick what room they want to go to, sure. I don't like any options. Okay, here it doesn't really matter, just that they can run away, and you put them somewhere. If you want to put them in a random location in the maze, sure. Like you ran around a maze and got lost, now you're in the middle of here. Sure, it doesn't have to make a lot of sense. Okay, just pick something. And then sleeping. When you sleep, you regain all your hit points, but there's a chance that a new NPC shows up, a 1 in 6 chance. So while you're sleeping, someone will wake up and start attacking you. Right? And then we could run away from that one too, or something. And the game just keeps going on forever. Right? We could get to all 100 rooms, and unless we die, it just runs forever. There's no like you win sort of condition. If you want to add a win condition, fantastic. That's fun. It doesn't. Again, that's other stuff to make it a slightly more interesting game. We just have some sort of function here. So we got 4 actions that happen with our 4 buttons. We got 4 navigations that can help us move around that maze and go up, go down. So you don't have to show the maze anywhere. You could tell them, hey, I'm at 0, 0, or I'm at 5, 5, I'm at 2, 7. If you want to tell them their X and Y, great. If you don't want to tell them the X and Y, don't tell them. It's your game here, right? Up to you. Drawing out the maze is not the hardest thing in the world to do, but again, it's a little more trouble than we really need to care about, right? So if we had a class for maze, that might be a really nice thing a class for maze did, and that maze class then had all the list of rooms, or the list of rooms. Sure, we got lots of choices here. So in terms of the scoring here then, right, your 2D array list of rooms, the room class itself, the player class, the NPC class, so having the classes, we get some points here, and then that it's a JavaFX program, and lets us search, JavaFX lets us sleep, JavaFX lets us run, JavaFX lets us fight. The other thing I didn't specify in here, I'm sorry, I thought I talked about it, but I must have totally forgot here. Victor, so if you want to have more than 100, that's great, but you got to have at least 10 by 10. Sorry. I think I have like zoom in that other screen here. So, and so now it's April 4th. We're going to present on the 25th, or for the online classes, they've got like the rest of the week to present because it's online. I can't have everyone show up and have 100 people presenting. It just doesn't work like that. So, but another requirement I forgot to add here. So we must have at least 10 different commits throughout April. Project with a single, or with less than 10 significant significant, can't spell, significant commits will not be scored. So you can't just wait to the very end, do one commit and say, here's my project. I need to see significant commits here showing progress throughout the way, right? The idea here is that you've done the work. Now you can go use some resources, find some examples online, it's perfectly fine. Cite your source, borrow some things from places, that's okay, but we need to piece it all together, make it work here, and build it out piece by piece by piece by piece. You can't just go find a solution you found online, cite it, turn it in all in one place. That's no good, right? So this got to be at least 10 commits. So lots of time for us to work. We're going to have time every week for us to work on this week, next week, and the 18th as well. We'll have at least those times to work. You'll have time we're working outside of that as well. And then we're presenting on the 25th at 6. So at least 10 commits throughout April. So not all on one day, right? Throughout, spread over multiple days throughout April. Okay. So you can't just commit it at the end. I need to see progress. So make your commits and push, make your commits and push, make your commits and push. So like if you look at our course repository, you can go to this commits button over here and you see there's 55 commits and you can see the dates of each of them, right? So I'll look at the history and see how many commits you made. You need at least 10 to show you've put in work throughout the time, little piece by little piece by little, and you can't just like change one thing. Like my update readme, it does not really count as a commit. I added one line here. May, depending on what your line is, maybe, but like changing one line is not a significant commit here. But like, hey, here's the whole Hello World project. That was probably larger than we needed. I think we were better at some of these. We did create tic-tac-toe was that, and then we did, what was our next one here? Game of tic-tac-toe. So like we had the class for tic-tac-toe, and then we had the game for tic-tac-toe. Like that's significant progress on these. Does that make sense? So like your player class could be one, your NPC class could be another, like as we're working on it. And if you gotta make changes, you make changes. That's okay. I thought I really added that in. That's super weird. Okay. How you feeling? So we're gonna take one little bit at a time. So if you just want to start with just get a player, get their stats showing, great. Then I can then add an NPC. Now it doesn't have to be attached to a room yet. Just add an NPC, get their stats going. Great. Now I can add the fight button. Does that work? Great. I can add a runaway button. Great. Again, you don't have to like change rooms yet. Just does it run away? Does it roll or die? Give them a random chance. That sort of thing. Do I want to add search? You probably need room to make search work, right? So maybe I add a single room. Great. Then maybe I can figure out the 2D list of rooms. So I think we've got enough to start on now. The idea with the 2D list is not too bad. And in our controller, right, we said, not in this one here, our shop example, sorry. Let me open up shop. And I'll get that committed here before I forget. So our shop controller had a, oh, I didn't add it there, shoot. I should have just added up here. So having to make a new shop every time is kind of obnoxious here, right? So the better way for us to do that, let me commit this and I'll show that. So this is 1500. Here is, so I don't need the demo. That was just I was just showing it there. We don't need demo. Don't need demo. Okay, here's week 12 shop. That was the exceptions. Let's do that. Let's do that one first. This way you can see it all in pieces here, right? Here's exceptions. And then here was the example layout. You're welcome to use the example layout. You're welcome to lay it out completely differently. All right, but anything that makes sense for you. So here's an example layout for project. If everyone uses it, it's really boring. That's okay. There's nothing wrong with boring, but it's fun to see other people come up with ideas. All the demo stuff I'll get rid of. Just go to demo. All right, cool. I'll push that. So in the controller, instead of making shop every time here, I can add a new class level variable because Hello Controller is just a Java class. So it doesn't have to be tied to FXML. So I can say, hey, I want a shop called shop. Then I can write a constructor, right? Hello Controller can have a constructor. So public Hello Controller is a constructor here. Now you also get the, I don't have initialize. Okay, that's fine. We'll say shop equals a new shop. Now all of this code here now doesn't need to make a new shop every time because I have my shop class level variable that I can use. I don't need to make a new instance of shop every time. So if you want to have a player, if you want to have the maze or the 2D list of rooms, right, you can make them class level variables and create instances of them in Hello Controller. Right? In the constructor, create the instance. The constructor's job is to give value to all your attributes. Now, anything fxml kind of happens magically. There's a step that happens. What is it here? When we load the fxml, it does some cool stuff automatically. Don't worry too much about it. So anything tagged fxml will get set up eventually. But we can add a controller for anything that's not an fxml. We can go and create an instance of it here, give it a value. So I might have the player, right? I might have my maze. I might need the player's location, their X and Y location, right? What room column index, what room row index, if I want to track where they're, because to go up and down, left and right, right? To go up is minus a row, to go down is plus a row, right? To go to your right is plus a column, to go to your left is minus a column, right? In that 2D array, if we look at like when we did tic-tac-toe, we have that 2D array, right? 0, 0 was the top left, 2, 2 is the bottom. We're just making it bigger now. And then we need valid values again too, right? I think, did we check for valid values, right? Making sure it wasn't less than 0 or more than 2. I think we did that in tic-tac-toe, right? So this is a class level variable in the controller now. Class level variable in controller. All right, so let me double check with tic-tac-toe. I think we had that one in here, right? That was a lab, wasn't it? Or arrays and array lists. Yeah, either one. I think we did it because I did it with array lists. You had to do it with arrays. So when you went to mark, right? Yeah. So we said, okay, if it's valid here, we're good because we knew it couldn't be less than 0 and it can't be more than 3, 3 or more because you only had 0, 1, and 2. So if you know if you can go up or down or left or right, if you're at row 0, there is no row above you. You can't go up. There's no row -1. Row 0 is the first row. If it's 10 by 10, right, the last row is 9. There is no 10. Right? So you have to make sure with whatever our bounds are here, we make sure they're valid. And you could even use lengths, which is probably even easier. So that way you could change the length of the maze. For tic-tac-toe, this was pretty easy. We could say that the row index is less than the board.size. Right? Board size would be 3 for a 3x3 tic-tac-toe board. Right? So if it's less than 3, oh, I'm sorry, greater than, or equal to. Greater than or equal to size, it is invalid. And same with column index. If it is greater than or equal to my board.size. Now, if you don't want it to be a square, rectangles are okay. So we could technically say, hey, let's get the row index and then get the size of that. So this is the size of the column. So if you wanted to make a crazy like 3x5 tic-tac-toe, sure, we can make a 3x5 tic-tac-toe, and we're going to check as long as it's a valid column based on the size of that column array. Yeah, column. Column is the length of that here. So this number of rows and this number of columns. So same idea with our maze is you go up, down, left to right. Just make sure it's in range here. And then rooms can be blocked or not, and you can't travel to rooms that are blocked. So if the blocked property is set to true, don't let them go there. So not only is it valid, is the room in that location not blocked? Will also tell us if we can go there or not. So again, the easy thing to do is just set them all to open or not blocked, or you could randomly set them to blocked. At some point, you might get a terrible game where you're just stuck. That's okay. It doesn't have to make a lot of sense. But having that attribute then lets someone actually make a real maze and say, okay, well, you can't go here, you can't go here, so you have to follow a certain path. And we can make like a 100 by 100 maze if we wanted to, with a bunch of monsters to fight in specific locations and whatever thing that might be somewhat sort of interesting as a game. Again, it's not like the prettiest thing here, so it's not going to be like a bestseller game at all, but game-like, in the form of a game, if that makes sense. Hopefully I'm not underselling it. And it's something you can work on and you can click on, and it's, I don't know if anyone want to play it, but it's something you can do rather than just we'll make a pretend shop. Okay? All right, awesome. So for the lab, we want to do some practice with exceptions here. So we've got, what was the last lab we did? Let me go find this here. We did lab 7, right? Was our shop class? Is that what we did? For 7? Oh, that was array. That was tic-tac-toe. Didn't we do another lab? Oh, I think I just did it in the shop program, right? We had a files lab, didn't we? I didn't do the files lab. That's right. We skipped it because we did the project instead. Yeah, so with the project with classes, and then we just went and modified that example with our shop project. So we added in some exception handling to this one here. So let's go to this. Let's go make a new new one here. Did I discard? Oh shoot! Was I supposed to discard changes? I might not have supposed to discard that. No, okay, I've got it here. Good. I was afraid I lost that. There weren't any, why is it asking me? I didn't have any changes. So let's add one more lab. Let's do that. So let's add a new lab. Lab 10 for exceptions. So what was the classes project we did? What was that? Was that project 2? Not remembering now. Yeah, with bottle. Okay. So let's go do that. So let's take our bottle project here from our classes and unit testing, and let's go modify this class because we already have the bottle class, or no, electric vehicle, right? So instead of just returning false, let's raise some exceptions. So just a quick lab just to practice using some exceptions here. So this will be lab 10. Do next week. So modify your electric vehicle class from project 2, or you're welcome to use mine if you want. Start. Update the charge and drive methods to throw exceptions instead of returning false if the value is invalid. There's ways to unit test it. Do you want to do a unit test, or you want to just, we should write main though, because the try catch is the important part here. So we're going to write a main method. So write a main method that allows the user to create a car, charge it, and drive it with exception handling to ensure the input is valid. So that's two different things, right? That's the number format, right? Number format exception, and the invalid argument. Valid argument, exception we just added for electric vehicle. Electric vehicle. All right, and then you need so just give me the repository. So submit the URL to the project 2 repository after it's updated. Does that make sense? So update your project 2, go clone it, go modify it, add the main method here. We'll just a quick little main to let the user enter some values, drive and charge. Make sure we're handling exceptions. Okay. So ideally that takes us a good maybe half hour, 45 minutes, and then we still got another hour or so to work on the final project after that. That sound good? All right. Awesome. Exceptions. Perfect. All right, folks. Thanks. I will see you next week then.